Moving on to 3.3, volume and capacity of prisms and cylinders. So we've been dealing with surface area, and now we're going to look at volume. So here it tells us that volume of an object is a measured start again. The volume of an object is a measure of the amount of space it occupies. So the physical space it occupies in space. If you were to look at it, how much space is it taking up? The capacity of an object is a measure of how much it can hold. So there is a slight difference here. It can be quite a big difference. Hollow objects, like a cardboard box, have a volume and a capacity. So if you think of a box folded up, it has a volume, but there could be a lot of things inside. It has a capacity to hold things. Whereas if it was a solid box with no inside, like a solid wooden block, then it has a volume, but it has no capacity to hold anything. So the capacity would be 0. So it just depends how hollow the object is as to its capacity. Volume is measured in cubed units, such as meters cubed, cubic meters, because when you calculate a volume, it's length times width times height. So many meters times so many meters times so many meters, the units end up being meters times meters times meters, or meters cubed. So capacity is measured in units such as liters or gallons. So there's a little bit of a difference there. Volume, meters cubed, and capacity, how much it holds, in liters or gallons typically. So liters is the SI unit, international unit, and gallons is the imperial unit used in the UK or the States. Volume and capacity are closely related. In a metric system, a volume of 1,000 cubic centimeters is equivalent to 1 liter in capacity. A volume of both a prism and a cylinder are found by multiplying the area of the base by the height of the object. So here's a formula. Whatever the base is times the height. The formula is the same even if the prism is a cylinder, even if it's an oblique. Just remember that the height is always the perpendicular distance between the two bases. Perpendicular distance between the two bases. So let's see, example 1. We have a rectangular prism that has a base of 15 centimeters by 12 centimeters and a height of 20. So it's set to draw a diagram. Diagrams are always a good idea. I'm not sure how well I can draw, but let's try and make something. Okay, its base is 15. Okay, let's do 15 by 12, 15 by 12, and then it's got a height of 20. Well, this is not going to be to scale, obviously. Not going to be to scale at all, so bear with me. I guess it's not really very good, but anyway, this is 20. What do we do scale? This is 12 and this is 15. So here is our height right here. Calculate the capacity of the prism. So, A was calculate the volume. It's a rectangular prism that has a base and a height. Okay, calculate the volume. Now in this case, if we assume it's hollow, it will have the same volume and capacity as long as it's hollow. So again, the volume is going to be equal to the area of the base area, times the height. So we're going to have 15 times 12 times the height of 20, and that would give us the answer. So here's the solution below. Just move down. and it goes through that right there. So here's now it tells you the volume here is 36, and it was in centimeters, so centimeters cubed, 3600 centimeters cubed. Remember, every 1000 centimeter cubed is equal to a liter. So because we have 3600, we actually have 3.6 liters. We're really dividing this by 1000 to see how many times 1000 will go into this, because every 1000 is a liter. And they get 3.6 liters. Example 2. Rectangular prism has a square base with side length 7. Its volume is 392 cubic centimeters. Calculate the height of the prism. It's always good to draw a diagram just so you know what it looks like, and you can refer to it as you calculate it. Rectangular prism with a square base, side lengths. Okay, so we have a square base. Draw it down here. So it's a square base. So, and it's got a certain height, which we don't know. Okay. Not very good at this, but there we go. Square base, and the side lengths are 7 by 7. By, we don't know what this is. I'm going to call it x, the height. Really, I guess we should call it h. Yeah, let's call it h, because that's what they're going to call it here. So the volume is going to be length times width times height, or 392 equals 7 times 7 times the height. So that's going to be 49 times h. So we're going to have to divide both sides by 49 to get the height of 7. So sometimes they ask us for the volume, sometimes they ask us for the length, width, or height if they give us the volume. And we can plug it into the formula, solve for the letter that is unknown. Third example here is calculate the volume and capacity of the following composite prism. I'm just going to cheat, see what they mean by capacity. I guess they're assuming that it is hollow. So, what do they do here? They're going to cut it into shapes that they can calculate the volume of. So they quite neatly cut this down here and basically divide it into two volumes, V1 and V2. So again, they need to know length, width, and height. So they know this width, they know this here, because it's in this part of the diagram here. 6.6, look to other parts of the diagram. This has to be 6.6 right here. So mark it into your diagram so that it can help you in the calculation. This is 7.5, so this is 7.5 here. And this is 4.2, so right here we have 4.2. And so the total 4.2 plus, this is 4.2 plus 7.5. So that's that side there. That equals 11.7. So now for this volume 1, we can go base, which is going to be the 9.4, the same as here, times 6.6, times the height of 11.7, and that's the calculation they're showing you right here. And they do the same for volume 2 as well. And there we have it. That's that section there. So I'll leave you to do all those build your skills questions, and we'll pause the video here before the next section will actually stop, and I'll make a separate video for the next section on starting on page 177.